Volatile organic compounds, or VOCs, are a class of carbon-based chemicals that evaporate or become volatile under normal indoor atmospheric conditions. VOCs are emitted from manufacturing processes, aerospace fuels, coatings and cleaning solvents, and vehicle exhaust. VOCs are also released from forest fires and contaminated sources such as chemical and fuel spills, landfills, and underground storage tanks. And through the process of vapor intrusion, VOCs can migrate from soil or groundwater contamination into buildings, which can lead to adverse health effects from inhalation. To identify and measure volatile organic compounds, R.J. Lee Group has combined state-of-the-art trace gas detection instrumentation with a commercial van to create the Mobile Organic Monitoring Laboratory. This transportable laboratory can screen the air quality of outdoor and indoor environments that must meet federal or state regulations for minimum levels of VOC concentrations and other airborne contamination. The mobile laboratory can detect a wide range of contaminants, including chlorinated solvents, BTEX compounds, PCBs, pesticides and agricultural emissions, and chemicals from smoke and fire. These and other airborne contaminants are measured by a full complement of advanced air monitoring instruments. A proton transfer reaction mass spectrometer analyzes traces of VOCs as low as a few parts per trillion in real time. The PTR-MS system has three main parts. In the hollow cathode ion source, water vapor is converted to hydronium, H3O+. In the drift tube reaction chamber, the hydronium interacts with a volatile organic compound taken from the environment. Because the H+ proton has a higher binding affinity to VOCs than to water or ambient air, this proton reaction occurs only in the presence of a volatile organic compound and not with components present in clean air. The protonated molecules then go through the mass spectrometer, which separates and identifies the ions according to their mass, allowing the user to know what VOCs are present in the sample. Air samples continuously flow through the drift tube without needing any carrier gas, and with switchable reagent ions, the system can detect other compounds with proton affinities below H2O using NO+ or O2+ as the reagent ion. The PTR-MS instrument aboard the mobile lab has several benefits. A continuous flow of sampled air can be monitored online and immediately in real time. It has a detection sensitivity to the parts per trillion range for common VOCs. It can analyze atmospheric gases without having to prepare or pre-treat samples before they are measured, and the system requires no carrier gas since air samples are collected directly into the drift tube. Supporting the PTR-MS system is a gas chromatograph mass spectrometer which follows EPA analytical methods with high sensitivity and confidence. The GCMS concentrates samples using thermal desorption, which provides automated and repeatable analysis of up to 50 tubes of collected samples. Whole air samples can also be stored in electropolished stainless steel canisters that preserve the sample's integrity during transportation. A carbon dioxide sensor and LGR methane analyzer provide precise CO2, methane, and carbon isotopic measurements. All of these instruments are powered by either the van's electrical generator or by a standard RV 50-amp power source. The mobile laboratory can operate in nearly any location accessible by the van. The integrated mast and weather station extend the reach of the mobile laboratory's outdoor air monitoring capability. The onboard weather station calculates wind speed and direction, barometric pressure, air temperature, relative humidity, and other atmospheric data. While driving in urban or rural areas, the mobile lab can graphically represent the locations and concentration levels of a contaminant plume in real time using GPS mapping data. While stationary, the mobile lab can measure variations in ambient air contamination within 24 hours. And with a flexible, lightweight sampling tube, the mobile laboratory can measure VOC concentrations in indoor environments at a distance of over 100 feet without any loss of monitoring sensitivity. Here are just a few applications for which the mobile laboratory is ideally suited: site and environmental monitoring, atmospheric research, air quality testing at military bases and air base hangars, agricultural air quality monitoring, air quality screening for worker safety, breath analysis as a medical diagnostic tool, vapor intrusion detection, measurement of chemical emissions of building materials, pharmaceutical, cosmetics and toiletry manufacturing, microelectronics manufacturing, and food research. Portability, fast response time, and low operating cost make the Mobile Organic Monitoring Laboratory an ideal air monitoring solution.